All right, so sampling methods. I'm going to introduce you to both non-random and random sampling methods. All right, so we're going to begin with non-random method sampling or non-random sampling methods, one of which is accidental sampling, sometimes called convenient sampling. And this occurs when a researcher includes the most convenient cases in their sample. As one great example of this is, if I want to learn about the culture of MSJC, then I might survey students in my classes, right? That's a convenience sample. Is it necessarily reflective of the larger population of MSJC students? No, right? And so we do have to keep in mind that when it comes to both non-random and random sampling methods, there are pros and cons. Convenience sampling is great if we're on a time crunch, we're on some sort of financial crunch. There are reasons why we might engage in this type of sampling, but it comes with its own challenges. Quota sampling occurs when diverse characteristics of a population, such as age, gender, social class, or ethnicity, are sampled in proportions they occupy in a population. If I'm studying MSJC students as my population, and let's say I learn that, and I actually think this might be the case, maybe around 52. I might be making that number up, to be honest, but let's just say, for the sake of what we're talking about, MSJC is designated as a Hispanic serving institution, in part because we have a very large Hispanic population at our within our campus, within our school. If we know, or if we learn that the proportion of Hispanic students at MSJC is representative of like 51%, then any sample that I draw, quota sampling would say, all right, well, make sure you have 51% of your sample being, Hispanic students. And so that's an example of quota sampling. And finally, we have purposive or judgment sampling, which occurs when logic, common sense, or sound judgment can be used to select a representative sample. And so in this case, we might say, well, I want to sample. I want to know about how students at MSJC are really taking advantage of the events that we have on campus. And so it makes perfect sense that if I'm trying to learn more about students in the context of attending events, then I'm going to attend an event myself to survey students who are attending the event, right? So that's an example of purposive sampling or judgment sampling. And then we have types of random sampling methods. So one example is simple random sampling, which gives every member of the population an equal chance of being selected. I'll give you a little heads up now that this particular method of random sampling is in kind of the foundation of the kind of sampling we are going to be using as like a theoretical foundation in our class. And what I mean by that is, in our class, I'm not asking you to develop a survey and then go out and survey people, which, if that were the case, we would have to develop a sampling method, right? How are we going to survey people? But in how we are going to discuss populations and how it is that we engage in this idea of conducting analysis based on the data that I'm providing for you, we kind of have to make an assumption that the data was collected through simple random sampling. Later, you're going to learn of it as sampling with replacement. And what that means is the idea that if everyone has an equal chance of being selected for a sample, then it's going to sound weird. Bear with me. Once we pull someone for our sample, we have to place them back. And that sounds odd, right? But let's say, for example, our population has 100 people. Okay, if our population has 100 people, then one person out of that, there's a 1 in 100 chance that I will draw any person from that, right? However, if I don't put that person back into the population pool, then the next person I draw is a 1 out of 99 probability of my drawing them, right? Because now the total is no longer 100. If I don't put that person back, it's only out of 99. So if at that point, I'm kind of manipulating the percentages by which someone can be selected for a sample, and then it's no longer simple random sampling. rather is and not rather, but it's also no longer sampling with replacement. So that's the kind of assumption that we make in terms of how it is that we collected the data that we're using in this class, or at least some of the data. Systematic sampling is drawing every nth member of a population where n represents a number. When I was in community college and I was taking this behavioral statistics class, the professor at the time required us to go out and survey students. I apologize. We weren't surveying students. We were surveying just like the general public, really. And so I went outside Walmart, and we had been instructed to survey every third person. And so what that means is I was counting. I was saying 1, 2, hey, are you willing to fill out a survey? 1, 2, hey, are you willing to fill out a survey? So it's not surveying every single person that comes by you, but you have a number in mind that you're using to determine who is the next member, potential next member of your sample. Stratified random sampling involves dividing the population into more homogeneous subgroups before drawing a sample. So, for example, if I were focused on studying race, the racial, something related to race, I would take my population and break them up into racial groups before drawing my sample from those groups. And then finally, cluster sampling or multi-stage sampling requires delineating an area that includes characteristics in the population. When I was discussing this type of sampling in another behavioral statistics course, someone asked the question, well, what does that mean? If I wanted to sample or if I wanted to conduct research on the Inland Empire, can I only sample Hemet and then I've engaged in cluster sampling? And if you decide to survey Hemet as the designation of a city, yes, you are engaging in cluster sampling. You can't only sample from Hemet to then generalize to the whole Inland Empire, because of course the Inland Empire is much larger than just Hemet. But what you can do is, if I'm studying Inland Empire, okay, I'm gonna draw, this number of people from Fontana. I'm gonna draw this number of people from Moreno Valley, this number of people from Riverside, this number of people from San Jacinto, so on and so forth. Okay, so that's cluster sampling. Okay, so actually, that's it for this video. So you're welcome that this one's short.